All right, so we got inverse functions and inverse trig functions. Right. All right, so when we did like our pre-calc review, we talked a little bit about what an inverse function is. So an inverse function, usually you have f to the -1 of x, and what that does is undoes the work of a function of f of x, right? So if I have like f of x is x cubed, what would the inverse be? That's the derivative. So what's the So if I'm cubing something, what's the opposite of that? Cube root, right? Right. So this function here undoes that, right? What's another one? We have, say, f of x is sine of x. What would the inverse be? Yeah. You guys probably didn't do a lot of it. All right, so arc sine or sine to the -1. That these mean the exact same thing. All right, so if I were to say do like, say I had sine of 5x is equal to, I don't know, 1. Right, what I could do is I could take the arc sine on both sides, just like inverse. Right, and what that arc sine does is that kind of cancels out the sine, and you're just left with 5x. You can just algebraically you can do that. You don't have to. It's just a function, like sine, cosine, tangent. Arc sine is another function. Yeah, you can plug values into it and get answers back. All right, now, function g of x is said to be the inverse if, now you guys will see kind of that notation sometimes on a multiple choice question where, they'll tell you that f and g are functions and this occurs, right? So if I plug in g of x into the f function, what I'm going to be left with is just x. And if I plug in the f of x function into g, I'll just be left with x. Okay? What that means is that everything kind of cancels out, and you're just left with x to the first. So if we had the one before, say I said f was x cubed, and then g was the cube root of x. Right? So if I compose these two, right, so that means I'm going to plug the cube root of x into x cubed. I would have cube root of x cubed, which is just x. And it would work. They're inverses, right? Yep. Right. So that's what, like this notation, that's what that means. That means that f and g are inverses of each other. So one can undo the other. Things like that. All right, so this means that the domain of f is the range of g. The domain of g is the range of f. So everything kind of just switches. All right? So what it means is if you have a point f of a is equal to b, that means that g of b is equal to a. So if I have a point, say 1, 2, and I know that g is the inverse to f, I know that g has a point at 2, 1. Right? The domain of f becomes the range of g. the range of f becomes the domain of G. So everything kind of just switches. All right. Now, what these points here are called? They're called corresponding points. All right. So this point corresponds with this point because they are inverses to each other. All right, because they have special properties occurring at both of those points. All right, so it says find the inverse functions for each of the following. So if I know that f is that, right, and I know g is the inverse of f, so what would I know the points? What would I know that G has points at? 5, 2. Right? Just because they're inverses doesn't mean that they are. You have to make them like opposites like that. You're just switching their locations really. What would the next point be? Right? And 2, -1. And then 7, 4. All right, so because f and g are inverses, again, this point corresponds with that point. This point corresponds with that point, and so on. All right? You guys ready for a quiz? All right, the next one is 5x minus 8. Now, we want to find the inverse function, right? So, kind of did it a little bit earlier in the year. So, what you're going to do is you have y equals 5x minus 8. So what? Right. So, right, you can switch them if you want, or you can take this equation, solve it for x, and then switch the x and y back. So, say again? Why did we use this last? That was like chapter 1, just like going over pre-calc stuff. All right, so I would have y plus 8 equals 5x. And then I have y plus 8 divided by 5 is equal to x. So I have 1/5 y plus 8 over 5 equals x. So then my equation, again, we've solved for x now. Now you just switch them back. So you have slope-intercept. Right. 1/5 x plus 8 over 5. Yeah, you should get the same answer. All right, so that would be your inverse. Now, what do you notice about the slope of f and then the slope of the inverse? Right. They are reciprocals to one another. Right, so that's going to happen all the time. So if you have a regular function and it has an inverse, its inverse function will have a reciprocal slope. All right? So the slope here is 5. The reciprocal of 5 turns into 1/5. Right. Yep. So it says the only way that you can find a inverse is if the function is what's called 1-to-1. Right? So that means that each x maps to only one y, and each y comes from only one x. Right? So what you can do is kind of test yourself called a horizontal line test. So if it passes both vertical and horizontal line test, then it has an inverse function. So if I had something like say something like this. Right, that looks kind of like a what? Right. So if I were to draw a vertical line through all my points, that would pass it, right? So every x gets mapped to one y. But then if I were to do a horizontal line going through the function, right, see how that horizontal line crosses there and there? So you have the same y value going to multiple x values. Okay, so this function here would not have an inverse because it doesn't pass that horizontal line test. So not cannot have an inverse. That's not a function. Now, if I had a different function, right, say something like, an x to the cubed, right, if I were to draw vertical lines through that, again, it's only going to cross it once, and then if I draw horizontal lines to that, that means that it's only going to pass it once. So if I had y equals x cubed, right, it passes both of those tests. That means I can find an inverse to this function. And then you would do your algebra to figure it out. All right, so can have inverse. Well, if it passes the vertical, that means it's a function. And then if it passes the horizontal, that means you can find an inverse function. All right, so if you look on the second page, the graph of a function and its inverse are reflections of each other across the line y equals x. All right, so you have a point, say the red line is f of x, okay, and then the blue line is its inverse, right? So I have a point here. I have a point here at 1, 0, right? So if it has an inverse, what's the corresponding point to that? 0, 1, right? Which is right here. So even if I didn't have that blue line on there, I could figure out, if I knew that f of x has an inverse, I know that if I have a point at 1, 0, I should have a point at 0, 1, right? So again, you're just switching them. Now, you see it's a little bit of a reflection. And what's this dotted line going through the middle? Y equals x, right? So anytime you have a graph of an original function, what you can do is just flip it over that line there, and that'll help you get the graph of the vertical, the inverse function, I mean. Y equals x, yes. Yeah. Now, at these particular points, they have, if you see on there on the left, they have inverse functions at corresponding points have reciprocal slopes. So we will pick that up. Have a good day, guys.